To another Grandmaster video. Today, I'm going to discuss the answers for Cambridge IGCSE Physics 2021 March Paper 1 Multiple Choice Questions. Before you continue to watch this past paper discussion, I recommend that you answer the questions by yourself. If you have already answered these questions, then check your answers with the following marking scheme answers. If you find these videos effective, please consider supporting us on Patreon or buy me a coffee. You can download all the printable PDF versions of these paper discussions on patreon.com. You can also find out my services on Fiverr. Also, don't forget to like, comment, share this video and to subscribe us, because that's really going to help our channel grow and encourage us to do more helpful videos for you. Let's move on to question 1. A student has a measuring cylinder containing water and also has a balance. Which of these could she use to find the volume of a small metal sphere? She has no other apparatus. In order to answer this question, look at the following experimental technique which you have learned in determining density of an irregular shaped object. In this experiment, we pour some water into measuring cylinder and obtain reading 1. Then we put the irregular shaped object into measuring cylinder and the water level goes up and reading 2 is obtained. Volume of the object can be found from the difference of 2 readings. So the same technique can be used to determine the volume of the small metal sphere. Therefore, the correct answer for this question 1 is answer B, the measuring cylinder containing water only. Let's move on to question 2. 2 rockets are launched at the same time from the surface of the Earth. The graph shows how the speeds of the rockets change with time. Observe the graph. Which statement about the rockets is correct? In order to answer this question, let's revise the features of a speed versus time graph. Gradient or the slope of speed time graph represents acceleration of the object. Greater the slope, higher the acceleration. Area under the graph, or the area between the curve and the x-axis, represents the distance traveled by the object during that time period. Now look at the graph for 2 rockets. Area under curve for rocket Q is less than the area under curve for rocket P. I can show this by shading out the areas under each graph. So if I shade area under rocket Q with red color, which is a red triangle, and I would shade the area under rocket P with yellow color. Now you can observe area shaded by yellow color is greater than the red color, which suggests that area under rocket P is greater than rocket Q. Therefore, rocket P travels further than rocket Q. So, the correct answer is answer C. Rocket P travels further than rocket Q. Let's also look at other answers. Since the correct answer is C, answer A is obviously wrong. which suggests that both rockets travel the same distance. And answer D is wrong, since a zero acceleration is represented with zero gradient line, which should be parallel to the x-axis. We don't have any graph which is parallel to the x-axis. Therefore, answer D is wrong. When considering answer B, let's first draw two tangents to the curve of the rocket P at two instances. I will use a different color. So here I'm drawing two tangents to the curve at two different instances, and one in the beginning and the other at the end, closer to the end. As you can see, both of these tangents make acute angles with the positive x direction, which suggests that they have positive gradients and therefore positive accelerations. A negative acceleration or a deceleration is represented with a negative gradient, where the line or the tangent makes an obtuse angle with the positive x direction. I will show it with a graph, example graph. So if we consider about this line, this blue color line, and this blue color line makes a obtuse angle with the positive x direction. This is the positive x direction. Therefore, we don't have any deceleration in rocket P or in rocket Q. Acceleration of rocket P is initially greater and it gradually decreases. We can understand this by considering the angles of the two tangents. Angle of the first tangent is greater than the angle of the second tangent, which suggests that gradient decreases. Therefore, the acceleration decreases. Remember, acceleration decreases, there is no deceleration. So, answer B is also wrong. Let's move on to question 3. A train begins a journey from a station and travels 60 kilometers in a time of 20 minutes. What is the average speed of the train? So the formula to calculate the speed of an object is speed equals distance over time. Here there are different forms or different arrangements of the same equation, which can be used to calculate each quantity, either distance, time, or speed. So you have to substitute the distance and time values to the formula, speed equal distance over time formula, which are given in kilometers and minutes. But the answers are given in meters per second. Therefore, units must be converted before substituting. Be careful on units. First, convert kilometers into meters. In order to do that, multiply kilometer value in by 1000. And then convert minutes into seconds simply by multiplying with 60. So the correct answer when calculated with these substituted values should be 50 meters per second. Answer C. Let's move on to question 4. What is weight? This is a very simple question. However, I will explain about this in detail. A force is basically a push or a pull. There are several types of forces, and you should know the definition of these forces, or at least you should have some understanding about these forces. Let's consider about several examples. Upthrust. It is the upward force from a liquid or a gas on objects which are in the liquid. Tension. It is the force in a stretched material. Friction. It is the force that opposes the motion of one material sliding past another. Drag forces, or air resistance or water resistance. These are some examples of drag forces. These drag forces are another type of friction on moving objects in fluids or in air or water. Then magnetic force. Attractive or repulsive force between magnetic poles. Then the weight. Weight is the gravitational attractive force on an object by a particular planet. Or in other words, if you have an object on Earth or near Earth's surface, the gravitational force exerted on that object by the Earth is called its weight. So the correct answer for this problem is answer C. Remember that there is a difference between mass and weight. Check out our video on mass and weight to know more about this. Let's move on to question 5. The diagram shows a bird in flight. The bird is flying in a horizontal direction to the right. In which direction does air resistance act on the bird? As I explained in previous question, drag force is another form of friction force which acts on objects moving in fluids or air or water. Air resistance and water resistance are examples of these drag forces. Remember the following properties of drag forces. Drag forces always act in opposite direction to the motion of the object, and the size of the drag force increases with the speed of the object. Faster the object moves, greater the drag force experienced by the object. There is no drag force is experienced by any object if that object is at rest in a fluid. So the correct answer for this question 5 should be answer D. Since the bird is flying to the right, drag force or the air resistance must be acting on the bird to the left. So the correct answer is answer D. Let's move on to question 6. A small bottle has a mass of 20 grams when empty. The volume of the bottle is 10 cubic centimeter. When full of liquid, the total mass is 150 grams. What is the density of the liquid? We know the definition of the density or the formula for density is mass over volume. So we have to know mass of the liquid and its volume. In order to do that, we would follow these steps shown in this diagram. We all know that we cannot measure, or we cannot simply put a liquid onto a balance in order to measure the mass, its mass. We always need a container in order to put a liquid. So in this case, we will use measuring cylinder, which we use to measure the volume of the liquid itself, to contain our liquid. First, we measure the mass of empty measuring cylinder. We take the reading. So in this problem, answer is reading is 20 grams, and then we put the liquid into the measuring cylinder. We can also obtain the volume of liquid using the measuring cylinder. In this question, that is 10 cubic centimeter. And then we measure the total mass of measuring cylinder with the liquid, which is 150 grams in this situation. Then we can obtain the mass of the liquid by subtracting the two readings. So 150 grams minus 20 grams gives us 130 grams, which is the mass of the liquid. When we divide it by the volume of 10 cubic centimeter, we get the answer as 13 grams per cubic centimeter. So our answer is answer C. Let's move on to question 7. A rocket is traveling vertically upwards. 3 vertical forces act on it. The thrust acts upward and is equal to 100,000 Newton. The weight acts downwards and is equal to 80,000 Newtons. What is the air resistance force acting on the rocket when it is traveling upwards at constant speed? So we know that there should be another force, which is the air resistance or the drag force. As I explained in question 5, drag forces act in opposite direction. So we can draw the direction of drag force in downward direction. Air resistance on the rocket therefore must be acting in downward direction. So answers B and D can be eliminated since they have given the direction as upward. In order to calculate the size of air resistance, we have to apply Newton's first law to this problem. Newton's first law states that if the forces on an object are balanced, the object will continue to do what it is already doing. If the object is stationary, it will remain stationary. If the object is moving, it will continue to move at the same speed and in the same direction. Since the rocket is moving with constant speed, forces on the rocket must be balanced. Therefore, total upward forces should be equal to total downward force. So we have upward force thrust and downward forces are weight and the drag. So thrust should be equal to weight and weight plus drag. Now let's substitute the values to this equation and calculate the air resistance. When we calculate the air resistance, we get answer 20,000 newtons. So the correct answer is answer A. Let's move on to question 8. Which energy source boils water to make steam in power stations? We have answers: energy from tides, energy from waves, hydroelectric energy, and nuclear energy. First, let's look at few methods of electricity production. Here you have tidal waves, wind, solar, nuclear, biomass, wave, hydroelectric energy, geothermal energy, coal energy. Remember, except in solar method, in most of all of the other electricity production methods, we use a generator. We use an electrical generator where the electricity is generated when a coil is turned or when a coil is vibrated in a magnetic field. So in order to understand this concept, you will have to study further about the generator, electric generator in your textbook. Except in solar, all the other systems use this generator. So in order to turn the coil in a generator, in most of the systems, there is a turbine. In a wind electricity production farm, we have wind turbines. In hydroelectric electricity plants, we have water turbines. And in other systems such as coal, geothermal, nuclear, we have steam turbines. So when either wind or water or steam passes through these turbines, turbines tend to rotate. As they are turned, the generator coil, which is attached to the turbines, also turned, which generates electricity by the generator. So, as I told you, remember that even in coal power plants, geothermal power plants, biomass power plants, nuclear power plants, we heat some amount of water to produce steam, and then that steam is transferred through steam turbine in order to generate electricity. So as you can see, the correct answer for this question should be answer D, which is nuclear energy. And we don't have the answers. We don't have other methods of electricity production. But also remember, even the coal, in coal power plants, we burn coal to produce steam from water and then send them through steam turbine to generate electricity. In biomass, we heat up we burn biomass and then use that heat to produce steam. In nuclear power also, as I shown in this upper diagram, we have a nuclear reactor which produces heat, and then using that heat, we produce steam. Then that steam is sent through a steam turbine, and turbine is connected to a generator to produce electricity. So the correct answer for question 8 should be answer D. Let's move on to next question, question 9. Two people X and Y sit on a seesaw as shown. X weighs 400 Newton and sits 1.5 from the pivot. The weight of the seesaw is 300 Newton and acts through the pivot. When the seesaw is balanced, the pivot pushes up on the seesaw with a force of 900 Newton. What is the weight of person Y and how far from the pivot is he sitting? In order to answer this problem, you should understand the following theoretical concepts. First, you should understand Newton's first law, which I explained earlier. So in this situation also, the whole system, the two people and the seesaw are not moving, therefore, or they are stationary, therefore the forces on the seesaw are balanced. So total upward forces should be equal to total downward forces. According to that, we can calculate the weight of a person Y. Since the total upward force is 900, total downward force is 400 plus 300, which is 700, plus the weight of Y. So if you subtract 700 from 900, you get the weight of Y, which is 200 Newtons. So answer should be either answer A or answer B. We can eliminate answer C and D. To get the distance of Y from the pivot, we have to use the concept of or the principle of moments. Principle of moments state that for a body which is in equilibrium, total clockwise moments about a given pivot equals to total anti-clockwise moments about the same pivot. So if you look at this diagram, we can use this concept, this principle of moments, to calculate the weight of the distance of y from the pivot. So let us consider that W1 as the weight of x and W2 as the weight of y. So now we know the two weights, which is 400 as for W1 and 200 for W2. And D1 can be considered as the distance of x from the pivot, which is 1.5 meters. D2, which is the distance of y from pivot, we don't know. So we get the